Okay, so this video is going to be the Chapter 7 review, so we're going to be talking about logarithms, natural logs, and exponentials. We're going to be condensing them, we're going to be expanding them, and then we're going to be solving them and graphing them. Okay, so first off, suppose you invest $2,500 at an annual interest rate of 3.2%. How much will you have in your account after 10 years? If I don't say compound continuously, then I don't use the PERT one. I use A times 1 plus R times T. Okay, so the amount that I start with is 2,500. It's a rate of 3.2%. So if for some reason you're really bad at converting these, if you divide whatever that number is by 100, it should get you the actual rate that I need in decimal, so 0.0032. Sorry, one too many zeros. 0.032. Okay, and then my time is 10 years. Okay, so I type all that in my calculator, and the amount that I have after that time period is 3,425.60. Remember, when we're talking about money, I want two decimal places. My next one, we're talking about population. I don't say compounded continuously, so I use the same equation. So my population of Latvia starts here. I got 13%. It is decreasing in 50 years. So I got the amount of 2067887. We are decreasing, so I need the minus. I change that to a decimal, so I could take 13 divided by 100, and then the time period is 50 years. So I type it in, 2067887 times 1 minus 0.13 times the time period of 50. So my population then is 1956. Do not round it. Do not give me the decimal. I don't want to round up a person, and then I also can't put part of a person in my answer. Okay, my next one, to one decimal place, how long will it take for you to double your money invested in a savings account with an annual interest rate of 5% compounded continuously? So I know it's A of t equals PERT because we're compounding it continuously, but I need to know how long will it take this time. So what I'm missing is t. Okay, so I'm trying to figure out how long it will take to double my money. So if I pick an amount, let's say I start with 500. My rate is 5%, so if I do 5 divided by 100, that's 0.05, and I'm looking for time. Okay, if I'm doubling 500, I should be in the end game wanting to have 1,000, but I don't know how long it's going to take me to get to that 1,000. Okay, so my first step would then be divide by 500 because we're trying to get that t by itself, so I need to get rid of the things that aren't attached to e. So then it would be 2 equals e to the 0.05t. Okay, technically, you could have, instead of doing 500 and 1,000, done a 1 here and a 2 here, because you're always going to be doubling, which should be multiplying by 2. Okay, to get rid of an e, we need to do the natural log. So the natural log of 2 equals, this cancels, 0.05t. I divide by 0.05. Okay, so make sure you close this parenthesis when you type it in. So I'm going to do the ln of 2 and my parenthesis and divide that answer by 0.05. So my time period to one decimal place is going to be 13.9 years. Okay, we're going to be condensing. So when I condense, that means I want it written with one logarithm. So first off, I have to send my numbers back if I have them, because I can't write it as one log if I have a 2 and a 7 sitting in front. So I got log base 3 of x squared, remember it becomes a power, plus log base 3 of y to the 7th. Plus sign means multiply, so I can write it with one base and then being multiplied. Oops. Okay, my next one, we send our numbers back if I have them. So log base 2 cubed minus log of x to the 4th. Oh, 2 cubed is 8, so I'm going to go ahead and write that as an 8. Okay, minus means divide, so I got log base 8 over x to the 4th. And I can't simplify any further, so that's my final answer. We're condensing it down to one logarithm. Okay, this time we're expanding. Let's do this one first. So expanding means I need more than one natural log or more than one log. Okay, so division means subtract, so I'm going to separate them by a subtraction sign. And then my last step is always to pull numbers forward if I need to here. So the natural log of 15 minus 8, natural log of z. My next one's a log. So first off, I need to figure out this square root. Remember, the exponent for this is 1 and the radical is 2, so I always write, if I'm writing it in a fraction, e over r. So I got log base 2 of 15x to the 1/2, and then I'm going to bring that forward to get rid of it so I can separate that 15 and x, because right now I can't separate it because that's square root. So if I want to separate it, right now it's being multiplied, so multiplication means addition, so log base 2 of 15 plus 1/2 log base 2 of x. The 1/2 follows suit along with the log base 2. Okay, write in logarithmic form, so that means that my answer needs to have a log. Okay, so I always start with the big number being my base here, so I go base, the other part of my log, and it's always equal to the power. So I got log base 5 over that 1 over 25 equals that power, -2. It always equals your power. Okay, evaluate the logarithm. So I'm going to set it equal to x. I go base power what it's equal to. Base power equals. So I go base to my power what it's equal to. So what number, when I plug it in for that x, can get me to 81 if possible, and 4 can. Okay, another option that you could do is the change of base. So I would take my bigger font size, so log of 81, over my smaller font size, log of 3. If I type that in my calculator, I take log of 81 and my parentheses divided by log of 3 and my parentheses, and it should get me 4 again. Okay, so if it says decimal places, that means I'm not going to be able to figure out, if I set it equal to x base power, what it's equal to. So 7 to the x is equal to 28. If it's talking about decimal places, this is probably not going to be a pretty number. Okay, so you're going to have to use change of base to solve it. So I'm going to do log of my big font size over log of my little font size. So I'm going to do log of 28 and my parentheses divided by log of 7 and my parentheses. And then it said 3 decimal places, so 1.712. Okay, my next one, we're trying to simplify this. So there's 2 different routes I could go. I could send this back, making it a power, in which case we'd multiply. Or, if I remember, natural log and e cancel, so it would just be 2 times 6, which is then 12. Okay, you could also type that in your calculator as long as you use the parentheses, and you'd get 12 as well. Okay, solve. So, 1, I could take the log of both sides and start it off, or I can see if I can break down my bases. So 3 to what can get me to 9? Well, 3 squared can. I follow suit with 4x. And then 3 to what can get me to 27? 3 can. If I have the same bases, I can cancel, so I have 2 times 4x is equal to 3. So 8x is equal to 3. Divide both sides by 8. So I got 3 over 8. My next one, we need to condense to be able to solve it. So that plus sign means to multiply, so it's going to be natural log of 5x is equal to 7. If I'm trying to get rid of that natural log, because I'm trying to get x by itself, I have to do the exponential of both sides. So 5x is equal to e, and then the power of 7, whatever number's over there becomes the power, and then we divide by 5 to get x by itself. So in my calculator, I'm typing e to the 7th divided by 5. So second ln should give you that e to the 7th. You might have to press the over button to then divide it by 5. And I get 219, let's say 0.327. Okay, the next one, I want to get rid of this log. I can't do the log of both sides because then I'll have 2 logs on the left side. So remember, this always is a base 10, so I go base power what it's equal to. So 10 cubed equals that 2x plus 5. 10 cubed should be 1,000. Equals 2x plus 5. We do some solving. So I'm going to subtract 5 to get 995 equals 2x and divide by 2 to get x is equal to 497.5. Again, you can double check all of your answers for these if you plug it back in for x and just type in that left side and make sure it equals 3. Okay, my next one, so I first off try to see if I can break it down. So 3 to some power, I can't get to 21. If I do 2 to some power doesn't get me to it. So what I need to do is take the log of both sides to get rid of the exponential, because right now it is an exponential. So I have log of 21 to 2x is equal to log of 129. If I have an exponent, I can bring them forward when we're talking about logs or natural logs. Okay, if I'm trying to solve for x, I need to get rid of the 2 in the log of 21. So I'm going to divide by 2 log of 21. So that it cancels, I just get x by itself. So when you type that in your calculator, make sure you end parentheses, and that whole bottom, if you're not using the fraction button, has to be in parentheses, because you want to tell the calculator that the 2 and the log of 21 are both in the bottom. It should also prompt you for a set of parentheses here. So you're going to have a double set of parentheses here. So I'm going to type in log of 129, and my parentheses divided by parenthesis 2 times log of 21, double end my parenthesis, and I get 0.798. If I go to this one, we're trying to get e by itself so that we can get rid of it and get x by itself. So I'm going to add 2, so get rid of the things not attached to it first. Divide by 3. So e to the 6x equals 17 over 3. To get rid of e, we do natural log, so it cancels. 6x equals natural log of 17 over 3. Divide by 6 to get rid of that. So when you type in your calculator, you make sure you end your parenthesis after this 13 divided by 3 so that you can divide the whole thing by 6. So I'm going to type in ln of 13 divided by 3, end my parenthesis, divide that by 6. I get 0.244. Okay. My next one, we're trying to solve for x, so we need to condense it first. So this minus sign here means divide. So I got log of x minus 7 divided by x is equal to 2. I go base power what it's equal to. When you're trying to get rid of logarithm, you got to convert it to exponential. So 10 squared equals x minus 7 over x. 10 squared is 100. We got to do some work to get x by itself. I cannot take x divided by x and cancel it, okay, because that minus 7 is attached to it. So we're going to move this bottom x over to get 100x is equal to x minus 7. I want my x's on one side, so I'm going to subtract this x to get 99x is equal to x, or negative 7. Divide by 99. So x is equal to negative 7 divided by 99, negative 0.07. Okay, and then you need to check that, because I don't think if I put a negative in for a logarithm it's going to work, in which case it doesn't, so you actually have no solution for this one, because you can't have a negative inside that logarithm. My next one here, if I'm trying to get x by itself, we need to do the natural log of both sides. So x equals the natural log of 7 divided by 3. I get 0.847. Okay, this one, let's see if we can go ahead and break them down. They both look even, so I think I could do 2s or 4s. If I did 4, 4 squared could get me to it. And I'm thinking 4 cubed. Yes. And then this whole thing follows suit, the 4x minus 3, but it needs to multiply by the whole thing. My bases cancel, so I got 2 equals 3 times 4x minus 3. We need to distribute it to get 12x minus 9 and go ahead and solve. So I'm going to add 9. Divide by 12. So x is equal to 11 over 12. Again, you could double check your answer by plugging it in for x here. Make sure you use parentheses and it should get you 16. My next one, 4x plus 10 is attached to the natural log, so I need to do e to get rid of it. So 4x plus 10 is equal to e cubed. We're going to try to get that x by itself, so 4x equals e cubed minus 10. Divide the whole thing by 4. So x is equal to e cubed minus 10, all divided by 4. You need to have that set in parentheses to show that it's together, and you're dividing it by 4. So I press second ln to get my e cubed after you do your first set of parentheses. So first set of parentheses, second ln. So cubed, you bump out, you do minus 10, end your parentheses, and divide that by 4. You get x is equal to 2.521. Okay, state the translation and asymptote. So this, remember, inside means left or right. It's opposite of what you think, so we're going left 6. If it was on the outside, it would be up or down. In the front would be stretch and compress. So if it's bigger than 1, it would stretch. If it's smaller than 1, it would compress. If it was negative, it would reflect over your x-axis. Okay, but right now we're just going to go left 6. So if I type in my calculator, I press y equals log of x plus 6. I end my parentheses. I press graph. I do a t-chart. When you guys are taking the test, I need your guys' t-chart, okay? But it should look something like this. If I press second graph, it will give me that table, and it looks like it's getting closer and closer to 0. Hold on, second table. Because if I keep scrolling the other way, it gets more than 1, more than 2, more than 3 if I keep scrolling. So y equals 0 is where it ends at. So it's actually y equals -1 because it's crossing over that 0. It's getting closer and closer to -1. Sorry. Okay, my next one. So translation. So this one's confusing. So this is like our set of parentheses. So we're going to be going the opposite direction of we think. So right 2. This is going to be the up or down. So down 1. Okay. A lot of people get this 1/3 confused. The 1/3 is the base of your formula. It's the parent function. In front of it is if it's stretching and compressing. There's nothing in front, so there's no stretch or compress or reflect. So the only things I have are right 2 and down 1. So if I graph it, I press y equals 1/3 power. I make sure that x minus 2 is up in the power with it. So you might need to use parentheses. And the -1's on the outside. I press graph. You guys are going to need to do the t-chart, so you press second and graph to get your t-chart. I'm just going to guesstimate this a little bit based on time here. So it looks like it's going, oops, like this here. So you're, ooh, that was really bad. So you're going to do the t-chart to be able to do it. Okay, I press second and graph to get my table to figure out what it's getting closer and closer to. And it looks like it's getting closer and closer to -1. So y equals -1 is my asymptote. Remember, the asymptote is the wall that it cannot cross.